Okay, so tonight's homework was to work on our our metric conversions, which are right over here. So again, the prefix relates to, instead of writing all of this or all of this, when we use this tera prefix, what that means is that we're actually saying either this or this, whichever way you want to think about it, means that. Okay? So that's where we're starting from, that base level of understanding. So let's try. I know that in most of our classes we got to number 2, but I think the last class kind of didn't get there. So it says for every 10 micrograms, there are so many grams. So we need to know the relationship between micrograms and grams. So if I scroll back over here, I find that micro is 10 to the negative 6, or 1/1,000,000th of a gram. So what that means is that I'm going to write this as, for every 1 microgram, there is 1/1,000,000th of a gram. We can also write that as 1 times 10 to the negative 6th of a gram, because that's what 1/1,000,000th is. Okay, so now we've got 10 micrograms, right? So we're going 10 times as much. So if this is multiplied by 10, then if we're looking for the number of grams, we're going to have to also multiply this by 10, which amounts to 10 over 1,000,000, which means that basically, if you think about this, I'm losing a 0, so that's 1 over 1 followed by 5 zeros, or you could think about it as 1 times 10 to the negative 5th grams. Let me clear. Okay, let's take a look at number 3 now. So it says for every 850 liters, there are so many kiloliters. So in this one, I've got to take a look at kilo, and kilo is bigger, right? So that means that there are 1,000 liters in 1 kiloliter, or 1 times 10 to the third. So I'm going to go back to that problem real quick. And again, I'm comparing liters to kiloliters. So I could say for every 1,000 liters, there is 1 kiloliter. Or I could think about this as 1 times 10 to the third. Either way. And so now I'm going to go ahead and say for every 850 liters, there is blank kiloliters. So if you think about it this way, this number went down, so I'm going to divide in order to get that, and I'm going to divide by 1.176. And I use my calculator to figure that out. And again, I should get a number that is bigger than 1, but it's going to be smaller than 2, because half of 1,000 would be 500. So it's got to be somewhere close to 1. So if I take 1 and divide it by 1.176, I get 0.850. Which makes sense because, again, I move this. If you think about 1,000, if you think about the relationship between 1,000 and 1, it's basically like moving the decimal 3 over to get to 1, which means that it's basically like moving the decimal 3 over to get to 0.85. This is why that math understanding is so important. Okay, and then number 4 has us comparing meters to millimeters. And if I take a look, here's millimeters right here. So for every 1/1000th of a meter, there's 1 millimeter. That's what that tells us. Or I could rewrite this as 1 times 10 to the negative third. Negative third. Because again, that's to the left 3. So over here, this is going to be 0.2 meters, and this one is the one that I'm trying to solve for. So in what way can I get to 0.2? Well, if I have 1/1000th, this is really 2 tenths. So that's going to be a bigger number than I started with. So I'm going to, this is 2 times 10 to the negative first. So really, if I multiply by 2 times 10 to the second, then I should end up with 2 times 10 to the negative first, or multiply this by 200. So this is going to be times 2 times 10 to the second, and 1 times 2 times 10 to the second is 200. Again, if you think about it this way, this number here is 0.001, and this number is 1. So realistically, all I did was move the decimal 1, 2, 3 to get from here to here, right? So if I move the decimal here, 1, 2, 3, I get 2 zeros on there. So this is all interrelated numbers, and that's kind of what we want you to see today, is how these numbers are interrelated. Let's do one more. For every 0.08 kilograms, there is a certain, actually we'll do these next two. For every 0.08 kilograms, there are a certain number of milligrams. So I'm going to show you a couple ways to do this. First of all, we can say for every 1 kilogram, there's 1,000 grams. And notice I'm not going to milligrams. I'm going to grams first. And we're going to talk about how to go directly to the other next. And this is 0.08. So if I multiply this by 0.08, and I multiply this by 0.08, then 1,000 times 0.08 is 80 grams. Okay, and then I'm going to go from kilograms to milligrams. So I'm going to use this space over here. For every, we're in grams now, and I want to go to milligrams. Blank grams, there are blank milligrams. And again, I can go back up and see that 1 milligram is 1/1000th of a gram, or 1 times 10 to the negative third of a gram. And so now I can come back and say, okay, well, I have 80 grams. How many milligrams is that? And again, so to get from 1/1000th to 80, well, I know that this is going to be a bigger number. 1/1000th is smaller than 80. So I'm going to multiply by 8 times 10 to the 5th. Because negative 3 and 5, if I add those two numbers together, which is what we're doing when we multiply exponents, I'm going to end up with 10 to the second, which is what 80, oh, I'm sorry, we should end up with 10 to the first. So this is 10 to the fourth, and 80 is 10 to the first, 8 times 10 to the first. So I'm going to multiply this one by 8 times 10 to the fourth, and I get 8, and then followed by 4 zeros, 80,000 milligrams. And the next one says that we're going from nano to kilo. So I'm going to do this one the quicker way on this one. So I'm going to do it as a 1-step instead of like we did number 5. We did that as a 2-step. So to get from nano to kilo, nano is right over here. Let me just draw it right here. That's 10 to the negative 9th. And kilo is over here. And the difference between those is 10 to the negative 9th and 10 to the 3rd. So that amounts to 12 zeros difference. In other words, it takes 1 times 10 to the 12th of these to give you 1 of the kilo. Okay. So let me come back to the problem as soon as I erase. Okay, so let's come back to the problem. We said that there's a 12 zero difference between those two. So for every 1 times 10 to the 12th nanoliters, there's 1 kiloliter. And so if I want to find out, this is, I'm going to count them up. This is 4 times 10 to the 7th. So 4 times 10 to the 7th nanoliters. There is blank kiloliters. So if I think about this, and I'm trying to go, oops, this is 10 to the 12th. Sorry about that. So if I think about this, I'm going from 10 to the 12th to 10 to the 7th. So that, and I'm going from 1 to 4. So hopefully we can see that I'm going to have to multiply by 4. And then this is going to reduce the number of zeros. So what I'm doing really is I'm multiplying by 10 to the negative 5th. In other words, if I start with 1 followed by 12 zeros, I'm going to have to divide by 1 followed by, oops, 1 followed by 5 zeros in order to get rid of 1, 2, 3, 4, 5, 1, 2, 3, 4, 5 zeros to end up with 1, 2, 3, 4, 5, 6, 7 zeros. So I'm multiplying by 4 times 10 to the negative 5th. So I'm increasing that value by 1, but I'm decreasing the number of zeros by 5. So then this number is going to be times 4 times 10 to the negative 5th, which means 1 kilo, the number 1 here is really 1 times 10 to the 0. So 1 times 4 is 4 times 10 to the 0 and negative 5. If I add 0 plus negative 5, I end up with 10 to the negative 5th. Okay, I hope that helps. Also, you can kind of see that relationship here. The difference between this and this is 12 zeros. The difference between this number and this number, well, 4 and 4 are the same, 10 to the 7 and 10 to the negative 5th, that is also 12 zeros. Hope that helps. We'll try a little bit more with this tomorrow. We're going to keep working with the scientific notation too.